Hey guys, welcome to yet another session on AWS. So today we will be looking at a very important concept, that is load balancers in AWS. So we will practically discuss what's the real use case of load balancer and how it is used in AWS. Okay. So first of all, let me show you. Let's go to the EC2 dashboard here on instances. So currently, see, I have a use case that I have an application and that application must be accessed by a client. I mean, from if he has the IP address, then he should be able to access my application. Okay, that is inside this server one, that is an EC2 instance. Okay, so this is server one. Okay, click here, public IP address, paste it. See, this is a dummy application and the content is this one. Okay, hello world, this is being displayed from application one. Okay, so right now this is happening. Okay, we have a client and if he has the IP address, suppose this is the IP address, via this IP address he can access this application. Okay, that's fine. Now suppose there are thousands of clients. Okay, and they all try to access this application at once. What will happen? The server will crash. Okay, you might have heard of uh, server crashes, or you might have experienced it also. Like I remember when our class 10th result used to come, or class 12th result, we were not able to access it. Okay, why? Because multiple people were trying to access that, which means that the application was not highly available. Okay, the server used to crash because server was not able to handle so much load. Okay, so that is what used to happen. So uh, as a like solution for this, what we can do is, instead of deploying our application in one EC2 instance or inside one server, we can deploy this same application into multiple server, right? So let us do that. So I have basically one server. I have to create more servers like this. So let's check. So there is server 2 and server 3. Let me start these. Okay. And then go to running. So basically I had created these servers, okay, to save some time. And the configurations that I have done inside the server, let me quickly give a walkthrough of the configurations. So if I go here and actions, and if I do launch mode like this, so basically we will just see the configurations that I have done currently. So this is the name of the server. This is the AMI, that is Amazon Linux we are using. Okay. Instance type is T2 micro. Key pair we have attached, and this is the security group that I have added. Inside the security group, I have added some rules that I will show you. Okay. And configuration 8 GB is fine. And in advanced details, when you click on advanced details, scroll to the bottom. Here you will see I have pasted this script. Okay. Yeah, so what is this script? This is a shell script. Okay. So I hope it's visible now. So basically, what I have done is I have installed HTTPD, started HTTPD, enabled it, and I have created this h1 tag inside which I have written this message, hello world, and I am pasting this in index.html. See, your application will require a web server. Okay, so we have installed HTTPD for that purpose, and once you install HTTPD, uh, this folder will be created where www html, and inside this html it expects a html file. So this is the html file which I have created, and all this I have done using one linux command only. Okay, this is the redirection symbol that print this message. Echo means printing. Okay, inside this location index.html. Okay, and then I have then clicked on launch instance. Okay, So in the similar way, I have created three EC2 instances. Okay. Now let's check the server 2. Copy the public IP address, paste it. See, you are getting the same message. This message is being displayed from application 2, and similarly for application 3 also, you will get the similar message only. Okay, so it's showing F1 because I might have not changed the message name. That's fine. Okay, these are different IPs and same application you are able to see. So let me show you via this diagram. So earlier we had one EC2 instance. Inside that we had our application, but currently we have three EC2 instances, right? So I hope this is visible. Yeah. Check this, and the client will be able to access this application. Okay. So, but one thing, guys, how are we accessing the application inside different EC2 instances? Currently, we are basically copying the public IP address and pasting it. Okay. So here we have copied this IP address and then we have pasted it. So we are able to access this application. Similarly, we via this IP address, we are able to access the application that is inside here. And via this IP address, we are able to access the application that is here. So these are three different IP addresses, right? Now suppose, uh, will this ever happen that suppose application is not, the server is not responding here, okay? So will you tell to the customers that I am giving you another IP address, paste this IP address and access it here? Huh? How will they remember this IP address, guys? Is it possible? No. And suppose this one is also not working, then you will tell, wait, I have another IP address. So you will give this IP address and then you will tell, check if this is running or not. So that is not possible. Okay. So this is where now you need load balancer. Okay. So instead of providing different IPs to the client, now load balancer will come into the picture and load balancer will manage your servers. See how that would be. Okay. So this is the current architecture of load balancer. So we have multiple clients here. They this is a load balancer. Okay, ALB here means application load balancer. So whenever they will request, they will try to access your application. The request will go through a load balancer, and they will have a domain. They will have a, can say, DNS name for this load balancer, using which they can access your application inside any of the servers. Okay, and that also a load balancer will take care. Okay, it will distribute the loads according to the client. So first let me show you practically, then you will have a better understanding. Create a load balancer. First you need target group. You must place your instances inside a target group. So this is, let's go to the target group. Currently we I had already created a target group, but let me create again. Okay, instances is fine. Target group name, let us give it a name, my new PG. Okay, HTTP 80 is fine. VPC is default. Click on next. So we have three instances. Select all the three instances. Go to 80. Click on include as pending below. Okay, click create target groups. So once the target groups are created, now you need to attach a load balancer to it. So currently you can see none associated, right? Click here on load balancer. No load balancer, create load balancer. So we will use application load balancer. Okay, this is the most common one. My new ALB. Okay, internet facing is fine. VPC default. Select availability zone. See, why it is recommending you to select to availability zone. Okay, so that I mean in the backend, it will place your servers here. Okay, so basically, even if a availability goes zone goes down, then also your application must be highly available. Okay, so say it says a load balancer node will be placed in each selected zone and will automatically scale in response to traffic. Okay, security group. Let me select the security group that I selected for my instances. Okay, 483 forward to target group. Now you need to select target group. So my new TG I had created. Okay, and rest everything is fine. Create load balancers. Now see, status here is provisioning. Okay, so it might take few minutes to provision. Okay, so right now if we check target groups also, my new target group, currently load balancer has not been associated, so it will take some time. Okay, 3 to 4 minutes it usually takes. So let's wait until the status here changes to provisioned or success. Okay, so let's wait. So yeah, guys, now you see the state has changed finally from provisioning to active. So now with this load balancer, I must be able to access this application. See, if I go to my target group also, so here you will see load balancer has been attached. Okay, so let's go to the load balancer. Here you they will provide you a DNS name. Copy this DNS name. Okay, paste it. See, now you are not providing the IP, but you are still getting the message. Now refresh. See, here you are getting app2. This means this, uh, I mean this server's response you are getting here. Okay. If I refresh again, app1, app2. So what is basically happening is your all the three EC2 instances that were running, now the loads have been distributed here. So let me show you. Now you are providing this uh, DNS name to the customer and the request is coming. Okay. So how is the request traveling? Let me show you that. So for, suppose the client one is trying to access. Okay. So the request will come here and load balancer will send it here. Okay, you go here. Good. Now again, client two wants to access. Request will go. He will send it here. The load balancer will send it here. Again, third request will send it here. Again, fourth request here. Fifth request here. Sixth request here. So the load will be evenly distributed. So load balancers generally follow round robin fashion. Okay, they will distribute the loads in a round robin fashion. Okay, so this was it. Now you are able to access this via this load balancer name. Now you can create hundreds of EC2 instances here attached to the load balancer, and the clients will still be able to access the application via this link, right? And as we move further, now you will say, sir, this link is also a bit difficult to remember. What is this alb.amazon.com? No. So in real time, we attach this to a DNS name. Actually, we have another AWS service, that is Route 53, that we will discuss when we move ahead. So for now, still it's better than accessing, like providing the copying the public IP address and then pasting it on the browser and then individually accessing it. No, so that is not a recommended practice. So even if you have 500 EC2 instances running, then also load balancer will easily like provision the requests and it will distribute the loads accordingly, right? So that was the practical. Let me recap what how we created this one. So first we created EC2 instances. I already showed you how EC2 instances had to be created. In the user data section, we pasted a script, okay, and then we created a target group. So after creating EC2 instances, I created a target group. Inside the target group, I registered three EC2 instances, okay, and after that, once the EC2 instances got registered, I created a load balancer, which was internet facing, and it was application load balancer. And I attached that target group to my load balancer. This target group I attached here. Okay. So that was it. Okay. And this is how we were being able to access the application. Now, even if I give you this URL, you will be able to access the application. And you don't need to see that from where you are getting the response. I mean, it is coming from server 1, server 2, or server 3, or you only require what your application must run fine. Okay. In the backend, what servers are being provisioned, you don't need to know that, right? So application must run fine. So this is how you can make your applications highly available. Okay. So thank you guys. That will be it from my side. And one more thing, actually two more things. See, if you are having a hard time in understanding what is instances, how this I have provisioned it, what is T2 micro and what is EC2, what is load balancer, what script I had written. Okay, so that's completely fine, guys. Okay, so when I explain you all these things, then it will be like very, very, very simple. Okay, so even if you are not understanding, that's completely okay. But if you have understood, okay, so try to practice it or watch the video once again and try to practice it on your own. Okay, first create instance, host an application there, try to access it using public IP address, copy this, paste it in the browser. Okay, then after that try to attach load balancer and then try to access it. So that's how you will learn. Okay, so that will be it. And the second thing is that after you are done, just do one thing, that delete your load balancers also. Okay, so first you need to deregister your target. Click here on deregister. Okay, and go to load balancer, actions, delete load balancer. So here you might type confirm, click on delete. Okay, so now you will not be charged. Okay, so these are chargeable services, so I recommend you to delete all of them after the practicals are done. Okay, and EC2 instances, since we are using T2 micro, so you will not be billed for them. Okay, T2 micro comes under the free tier. That's okay, but still if you are done, you can either stop it or terminate it. Okay, so that will be it from my side, guys. I hope you understood the use case of load balancer, and we will meet. And if you have not understood anything, if you have any doubts, then you can ask me in the sessions when we meet there. Okay, so I hope you understood something today and you learned something. Try experimenting and try to do this practically. Okay, so thank you guys. That will be it from my side. Take care. Bye bye.